Hi, this is Kent Lee and I teach computer science at Luther College. In the last few videos we've looked at type conversions and how to convert between different types, between integers and floats, between strings and integers and strings and floats. In this video I hope to show you how to use some of that knowledge, some of that type conversion capability that we have to convert between units of measure. And I'm also going to show you how to format output so that it looks nice when you print it to the screen. So we have here this program that I have put together that computed before it computed the volume of a solid, and I've modified it slightly so that it asks me for the width, the height, and the depth of a container and computes the volume of that container. It's really the same program, just with a little bit different prompt. On the first line here, we go ahead and prompt the user to enter the width, and remember that input returns a string, and I convert that string to a float by putting float in around it. So I've got the left parent and the right parent and float around the whole thing. I do the same thing with height and depth, so I have three floats, and then I can multiply those three floats times each other to get the volume. If I run this just to see how it works here, give it a run, I can enter, for example, 5.3, and let's say I've got a cube this time, so I've got the same width, depth, and height, and my volume comes out to about 149, and we know that there is some round off error here because we can only represent a finite number of floats and there are an infinite number of real numbers. So floating point numbers are necessarily going to be approximations of real numbers. We can't represent every real number. So we have a little bit of round off here, but it's very close to that result anyway. Okay, so let's say that we want to change this program now so that we ask the user to enter centimeters for the width, the height, and the depth, but then we go on to compute how many gallons of water this could possibly hold. So I'm going to go ahead and leave the program as it is, but I'm going to go ahead and ask or compute how many ounces. I'm going to start with the smallest unit of measure and compute how many ounces we would have for this volume, how many ounces of water. And I happen to have looked up and found that the cc's, the volume that we have is in cc's, or cubic centimeters, and I happen to know that every ounce of water contains about 30 cc's. So what I'm going to do is take my volume here and divide it by the number of cc's per ounce. So I'm going to divide it by, and the amount I'm going to divide it by is, the value is 29.573529.688. So that's very close to the exact conversion that I would need there. So I end up with a number of ounces here, and I could go ahead and print the number of ounces if I wanted to see how many ounces there were. But I want to be able to display how many gallons and how many ounces. So here's where some type conversion can come in handy, because now that I have the number of ounces, which is likely some odd number of ounces, I guess we could measure here somewhat anyway. We could say, let's see, if there's 100, for this volume anyway, if there's 148, 149 cc's or so, if we divided by 30, we'd have about 50 ounces, and it wouldn't be quite a gallon. So, in fact, a gallon is 128 ounces. So we can use that actually and figure out how many gallons we might have, and we might as well go ahead and do that right now. So our gallons would be equal to the ounces divided by 128. Now, when I do this, I'm going to get some fractional part. So let's just go ahead and print the number of gallons that we would have, number of gallons contained, I probably should say of water, in this container could be, not that it necessarily contains water right now, and we could go ahead and print gallons. Let's just give this a run and see. So I could enter my 5.3, 5.3, 5.3, and it tells me roughly a third of a gallon or so is how much I would have. Now, that's of course not a whole gallon, and it would be nice to say how many gallons and how many ounces. And in fact, if I had a bigger amount, let's pick some bigger amount here. Let's pick that we've got 10.5 by 48 by 17.6. So there I've got 2.34 something gallons. Now it would be nice to say I've got 2 gallons and some number of ounces. So given this value that I have here, if I could get just the integer portion of this, I could find out exactly how many gallons I have. So in fact, if I want the integer portion, if I put int around this ounces divided by gallons, I'll find out exactly how many gallons I have as an integer value instead of the floating point value. Well, if I want then to know how many ounces I have left over, I could go ahead and subtract that from the amount that I've got. So for example here, I could say that ounces now is equal to, well, whatever number of ounces I had before minus the number of gallons I've got, but there are 128 ounces in a gallon, so I'll convert that gallons that I have to ounces, and I'll have just what the number of ounces is, and then I could add to my print statement down here and say and then I will go ahead and add here ounces. So let's go ahead and run this one more time and see what I get now. So if I have, again, I'm just making up some values here, but if I have 48.3 and 23.2 and 17.6, I can see here that I have 5 gallons and 26.87 and a bunch of other digits there, ounces. So here I was able to convert from cc's into gallons and ounces with the exact number of gallons as an integer, and I was able to use some type conversion to do that. By converting this float to an int here, I got just the integer number of gallons that I needed, and then I was able to use that and subtract that from the number of ounces that were left from before. So you notice here I have a situation here where I'm taking, and the way to read this is the old number of ounces minus the number of gallons I've got here converted to ounces, and that gives me my new number of ounces that I'm working with. Okay, so it would be nice to format this a little nicer so that I had a little bit nicer format for all of this. And I would especially, of course the integer isn't a problem, but I'd sure like for this to be to look a little different. Might be nice just to go to 2 decimal places, for example. We don't need to go out that many decimal places. Turns out that you can do that pretty easily in Python, and I thought maybe I would show you just a few of these. These are called format strings that you can use. So if I have a floating point number and I want to format it nicely, let's say that I've got a floating point number with a whole bunch of digits in it. What I can do is use a format string, and the format string starts out with a quote, of course, and then you specify the width, the total width of the field that you want to print. So let's say that, and if you specify something smaller than the total width, it's still going to print the whole number. It's just not going to print it's just not going to leave space to the left of it, as we'll see here in a moment. So let's say that I'll start out with a percent sign. Every format string has to start with a percent sign. And then I'll start out with a 1 dot. The dot says there's where the decimal point goes. And let's have 2 places to the right of the decimal. So this says have one, make the field 1 character wide, which actually does not mean 1 character. It means a minimum of 1 character, but it can be wider if it needs to be. Put the decimal point, have 2 places to the right of the decimal point, and format a float. So F is for float there. Then we'll put a quote and another percent sign, and then the floating point number that we want to format. So let's say we got 125 point and we got a whole bunch of 9s, let's say. If I press enter here, I get a float that's formatted exactly according to this format string. So it's a minimum of 1 character wide. It happens to be 1, 2, 3, 4, 5, 6, including the decimal point there. So it happens to be 6 characters wide. And I have 2 decimal places to the right, and I've rounded that so that it looks right for those 2 decimal places. So this is exactly what I want. This format string does exactly what I want here. Turns out there are other format strings too. You can actually format an integer if you want to. So D is for integers, decimal value. %5D would say create a field 5 characters wide. So let's say I had the integer 125. So I've got a string that I get as a result 125 with 2 blanks to the left of it. So you can line things up in columns nicely that way. And it turns out I can format strings as well if I want to, which is nice if you want to control the width of a field for strings. So if I say 4S, for example, let's say 10S, for example, and I want to format, say, Kent in a string, what I get is a string that is 10 characters wide, and Kent is right justified within there. So we can do floats, we can do decimal points or integers, and we can do strings with these format strings. Up here, if I want to format my number of ounces, then I need to put the format string first. I can do it one of 2 ways. I could put the format string right in with the and, or I could just do it separately. I think I'll do it separately here. And it's a %1.f, 1.2f percent. And then I'll get ounces formatted nicely here. So let's give this a shot and see what we'd end up with. 48.3, 23.2, and 17.6. See if I can remember that. So 48.3, 23.2, and 17.6. And now I get 5 gallons and 26.88 ounces, which is rounded to the nearest hundredth, which is exactly what I'd like. And I've got 2 decimal places there. The output looks much nicer. So I hope you've seen here in this video that you can use these type conversions to do conversion between different units of measure. You've also learned something about how to format output with format strings. These may be useful to you in some of the programs you are going to write very soon.